R denote the set of all real numbers, and the function f from R to R defined by f of x is equal to 2 minus 2x square minus x square into sin 1 by x if x is not 0, and f of x is 2 if x equal to 0. Then which one of the following statement is true we should find. Okay. Here the first option they give about differentiability of the function at x equal to 0. So we can check it first, that is only at x equal to 0. Okay. Whether it is differentiable or not, we have to check it. Left hand derivative is, formula is what now? Limit h tends to 0, f of 0 minus h minus f of 0 by minus h only. That means what? Limit h tends to 0, 0 minus h, right? So minus h if we substitute. So this is the function we should take. When you substitute in the place of x as minus h, what happens? See, 2 minus 2h square minus h square into sine of minus 1 by h minus exactly function value f of 0 is 2 by minus h. Minus 2 plus 2 both are cancelled only. Now we can take h is common from this and then we can strike out with the denominator. Then we will get limit h tends to 0. The balance terms are minus 2h minus h into sine of minus 1 by h, right? So this minus, if we take it outside, it will be plus 1 by h by denominator h only cancelled, so minus 1 is there. Now if we substitute in the place of h as 0 here, it is the term going to be 0, and 0 into sine infinity we will get. We know that sine infinity value is oscillate from minus 1 to 1 only, but we cannot decide that exact value is what, but it's the finite value. Any finite value into 0 means 0 only, so the entire value will become now 0. Similarly, right hand derivative, limit h tends to 0, f of 0 plus h minus f of 0 by h only. Now substitute limit h tends to 0, f of h means what? 2 minus 2h square minus h square into sine of 1 by h minus f of 0 means exactly 2 only by what? H. Minus 2 plus 2 both are cancelled. Now again h we can take common and then we can strike out here. The balance is what? Minus 2h minus h into sine of 1 by h. Okay. Now what was the value here? See, when you substitute in the place of h as 0, 0 only, and 0 into any finite value only, no? So you'll get 0. So LHD equal to RHD clearly. So function is differentiable at x equal to 0, and exactly the derivative value at x equal to 0 is what now? 0 only we will get. Okay. But they gave here function is what now? Not differentiable at x equal to 0. So option A is wrong. Next. There is a positive real number delta such that f is decreasing function in the interval 0 to delta they give, right? So here delta is what? Delta is any positive number, right? See, delta is any positive number. Now we have to check in the interval 0 to delta, the function is differentiable or not only, decreasing or not only, we have to check it, right? Okay. 0 to delta means what? Right side of 0 only. So let's take it as 0 plus clearly, which is belongs to 0 comma delta. So at this point we are checking. At this point the function differentiation, derivative of the function at this point only we are checking first. For the purpose we can find what is f dash of x, right? First of all. So what is f dash of x actually? F dash of x derivative we can find, right? 2 derivative is 0. Next, minus 2x square derivative is what? Minus 4x. Minus x square into sine 1 by x is there, no? Minus x square derivative is minus 2x, that time sine of 1 by x as it is. Next, here minus x square we can keep it as it is. Now sine 1 by x derivative is what? Cos of 1 by x, and again chain rule apply means minus 1 by x square you will get it. Okay. Now this x square is what? Cancelled. What is the balance terms? Minus 4x minus 2x into sine of 1 by x minus into minus plus, no, plus cos of 1 by x we will get it. Okay. Next, now see here, it is f dash of x, right? Now we are checking when you substitute 0 plus here, what happened? 0 plus when you substitute f dash of 0 plus value. So don't think it is right hand derivative at x equal to 0. It is the meaning exactly whenever you are taking, it is the interval 0 to delta. Here 0 plus is there. At this point exactly I am checking the derivative. Okay. See now here. What happened now? Minus 4 into 0 plus means what? It's going to very minute 0 only approximately. And when you substitute here also, it is also close to 0. It is also tends to 0. It is not exactly but almost close to 0. Plus Here what happened now? Cos 0 means it is again from minus 1 to plus 1 only, no? These are very close to 0 and it is the value from minus 1 to 1. So that means what? The entire value, entire derivative value at x equal to 0 plus, it will oscillate from negative to positive continuously in this interval, right? So that means what? The function is completely not decreasing, completely not increasing in this interval 0 to delta. So we cannot say the function is decreasing or increasing in the interval 0 to delta. So it is not a monotonic function. That's why here it is not decreasing, not increasing. But they give what now? There is a positive real number delta such that f is decreasing the function they mentioned, but it is not decreasing, not increasing in the interval 0 to delta, right? So option B is wrong. And they mentioned what now here? For any positive real number delta, the function is not increasing function on the interval minus delta to 0. So even you are taking minus delta to 0 also. 0 minus is there clearly from minus delta to 0. Even you substitute the 0 minus value also, it is also close to 0 and it is also close to 0 only. Okay, and we will get finally here cos of infinity only. Cos infinity means what again now? Minus 1 to 1 only. So even if you are taking 0 minus also, f dash of 0 minus also, the values from negative to positive continuously will oscillate. So in minus delta to 0 also, the function is completely not decreasing, completely not increasing. Okay, so option C. What is the mention of here? Option C. For any positive in real number delta, the function not increasing only they gave. Here we got that is only, right? It is not increasing continuously, not decreasing continuously. I am not saying here decreasing. I am saying it is not decreasing, not increasing only. So option C is possible answer, right? Next, option D is what? At x equal to 0, x equal to 0 is a point of local minimum of f they give, right? Let's check it now. We know that exactly f of 0 value is what? 2, right? Now 0 minus 0 plus, at that time what is the function value? We can check it. Okay, see here, f of 0 exactly what we have now? 2, right? Now we can check it. F of 0 minus or 0 plus means what is the function value? First of all, you can see f of x means, can you write this one as 2 minus x square? If we take it as common, we can write as 2 plus sine 1 by x. We can write now like this when you take minus x square is common. Now we know that sine range is what now? Always minus 1 to 1 only. And for that, if we are adding 2, if we are added 2, this range will become what now? 1 to 3 only, no? This value completely, see, minus 1 less than or equal to sine 1 by x less than or equal to 1 actually. Now whenever you added 2, what happened now? 2 less than or equal to 2 plus sine 1 by x is less than or equal to 3 we will get, right? That means what? Clearly it's a positive value. 2 to 3 means, see, whenever you added 2, sorry, here 2 added, no? So 2 minus 1, 1, right? 1 to 3 we will get, right? 1 to 3 means clearly it's a positive value. For any positive value, x square multiplied means then that is also positive. So clearly observe now here, x square into 2 plus sine 1 by x value always positive strictly, because here we are checking whenever it is, when x is not equal to 0, that case I am saying strictly positive, right? Even we want that is only, no? See here, what we want? F of 0 plus or minus value, right? If you take 0 minus or 0 plus, always it is what? Positive only. So we will get now 2 minus any positive value only. 2 minus positive means what? Compared to always small only, always small only. So the graph also, if you see here, it is the maximum value we will get 2, right? 2 only maximum, because 0 left side, 0 right side, it will become 2 minus positive value. That means compared to small we will get. So clearly the function has no local minima at x equal to 0. In fact, at x equal to 0, the point is what? Local maximum possibilities are there. So option D is false statement. Clear? So only option C is correct, valid one.